So I guess my job today is to channel John the best I can. So I'm going to grow to about 6'3" and get a very deep voice and tell you about a project that he has been working on with NASA for the last couple of years. 2 years ago, NASA funded an education effort that blended the scientific expertise at NASA with the educational expertise of the National Park Service. And through this program, a team of people selected a variety of topics to work on, and John began working on the climate change initiative that became the Earth to Sky program that the National Park Service is working on with NASA. And this program is focused on developing specific educational products, programs, and training sessions that can be used throughout the National Park Service, throughout the whole country, not just Alaska, with these variety of topics. So what we're going to look at today is the beginning of a training tool that John has been developing with NASA, focused specifically on informal interpretation. And informal interpretation, John thinks, and I agree, is one of the most difficult forms of interpretation to do. Almost anyone can stand at a visitor center desk or can talk to someone on a trail and provide them with information, with basic information, with in-depth information, but to truly create opportunities that provide opportunities for visitors or participants to make new connections, to think in broader and deeper ways, to feel new things, and to have those insights is very difficult. And the main reason is that the interpreter is not in charge. They're not in charge of the contact. They are following the lead of the questions that the visitors are asking. So we're going to take a walk through just a portion of the training tool that John is developing to work on this very thing. As with all of our interpretation in the National Park Service, he is attempting to use the very best science and the very best evidence that is out there. And this is a growing body of evidence, as we have seen for the last couple of days. And it's true, visitors are asking questions. Very few places in the National Park Service throughout the parks do we have formal programs on climate change. But we get asked a lot of questions at those visitor center desks about climate change. And so let's think of climate change and how we go through this process as a decision tree and examine what this might look like. Its branches might represent the various implications of change. And we have seen through the last few days that there are many implications of climate change in our national parks and natural environments. So the global climate is now warming at an unprecedented rate, and much larger changes are projected. And these might be some of the changes, or some of the questions that visitors are asking, among a whole host of others. I can tell you from personal experience, the most common question I get asked, which isn't even up here, and is a predecessor to all of these, is, so what do you think? I'm serious, it's the most common question. But this one up on the left is the follow-up to that question. Is it just natural climate variability? They usually don't use the word variability, but that sense, that is the question. So let's take a look at that question and how one, as a frontline interpreter, a seasonal interpreter, working with visitors every day, answering questions, might go through a decision tree as to how they might answer this question. And one of the things that we teach interpreters is to avoid the fire hose. So we might start out with a bit of a basic response. Current research reflects a scientific consensus that the climate changes being experienced today cannot be attributed to natural variability alone. There is a long history of changes in Earth climate. There are periodic ice ages interspersed with interglacial periods of warming going back for hundreds of thousands of years. However, over the past 1,000 years, a leveling off in temperature has occurred that is unprecedented. Continuing with basic. In the past 125 years, the average temperature of the planet has begun to rise, and the increase is accelerating. At the same time, carbon dioxide in the atmosphere has risen to its highest concentrations in more than 650,000 years, and its rise is also accelerating. CO2 concentration is projected to double by 2100, a change contributed to human activities which are releasing CO2 in the atmosphere. Scientists suspect this may be interfering with the Earth's natural balancing that has occurred prior to now. So a basic response, what does a basic response do? This response might allow visitors to understand a little bit more about general climate change, but it really probably is not providing an opportunity for them to connect to Denali, to Regal St. Elias, to Yukon Charlie, to Gates, to a specific place. And we know that the power of the parks are in their place. But we want to provide some information. So there are a variety of places that John is working on and researching to put together that will be easy places for interpreters to go to get basics on climate change. And one of the places that they'll be referred to is the Intergovernmental Panel on Climate Change. Another is the Arctic Climate Impact Assessment. So if a visitor has been asking questions and they're nodding and they're maybe asking a follow-up question, if they're nudging their spouse and kind of, yeah, this is what we were talking about, they might be indicating that maybe they want a little more in-depth answer. If they're kind of looking the other way and shuffling out the door, it might be time to cut it off and let them go on their hike. But if it looks like they might want a more in-depth answer, you might be able to go with something like this. Climate is the long-term statistical expression of short-term weather. It's important to understand that at many times in Earth's geologic history, there have been cooler and warmer periods than at present. Those variations were due to large-scale global influences such as volcanism, relative movement of the continental and oceanic plates, and even meteor impacts. Remember the dinosaurs? No. The following charts are intended to provide a fundamental background on Earth's paleohistory of recent times, like within the past million years or so. So let's take a look at this chart. Now you're still the visitor. I'm going to show them this. And in this, we can see that the mean annual temperature changes for Alaska have been steadily rising. And let's take a look at this one. Global mean temperature over the past 125 years has been, in 2005, is the highest on record. And look at this one. In Greenland, you can see that there's a plateau that's leveling off at a higher temperature. Oh, and let's take a look at a comparison between temperature and CO2 concentration in the atmosphere. And you can see this very strong correlation on these graphs between the two. So that might look like an in-depth, informative response. But again, it's not an interpretive response. And so how do we go about training our staff to interpret climate change? And so let's take a look at what that might look like. An interpretive response. After explaining the periodic cooling and warming of the planet, multiple times in its history, and maybe showing them some of the graphs that we just looked like, you might ask the visitor what they imagine might cause such changes. What do you think? What have you heard? How do you think this might work? Discuss with them some of the possible catalysts. This might be a place that we could bring in the power of place. And this is the place, I think, where it's important that our interpreters know what is happening in their parks. At Wrangell St. Elias, where I work, this might look like stepping outside of the visitor center, standing in front of the Kennecott Glacier, looking out across it at Fireweed Mountain on the other side, looking down at the glacier and handing them a photograph taken in that very same place that doesn't see fireweed on the other side, because between where they're standing and that mountain is a wall of ice. And I've handed that photograph to many visitors, and I have to point out that it's taken where they're standing. And the answer that I get is, wow. Honey, come look at this. They're hooked. When they've asked me what I think, and I've said, well, it doesn't matter what I think. Let's go look and see what you think. And once they're hooked with that, once they can see what's in front of them that's changed, not some theoretical graph off somewhere else, but the very park that they've spent a lot of money and a lot of time to come visit because they love parks, they're hooked. And from there, we can talk about the change in timing of the Hidden Lake outburst flood that goes down the Kennecott River every year. From there, we can talk about the thermokarst. From there, we can talk about the draining of the ponds and lakes through the permafrost. From there, we can talk about Mike Losso's varves at Iceberg Lake. From there, we can talk about what's really happening in the place, in the landscape that they're looking at. And from that, once we've been able to discuss with them some of the possible catalysts and from some of the connections to the actual place, we might be able to help them understand how the changes in the atmosphere can have such big impacts and inspire them to look for solutions, or at least ways that might help mitigate or adapt to the problem. Using interpretive techniques, we can talk about the significance, the meanings behind what we're looking at, behind the research that many of you are doing in our parks, and help visitors think in newer and broader, deeper ways. And so an interpretive response might provoke a deeper understanding as well as evoke awe or amazement for the ways that climate factors interact, particularly in our parks that they love. Am I out of time? All right. Thank you very much.